learners, as in previous video, we calculated two unit vectors er cap and e theta cap. Now it's time to get the value of third unit vector, that is e phi cap. In this video, we also cover the topics of velocity and acceleration of a particle in spherical polar coordinates.
We get change in position delta r equal to r sin theta cos phi plus d phi minus cos phi I cap plus r sin theta sin phi plus d phi minus sin phi j cap, using the relation cos phi plus d phi minus cos phi equal to minus sin phi d phi and sin phi plus d phi minus sin phi equal to cos phi d phi. Delta r becomes equal to minus r sin theta sin phi d phi I cap plus r sin theta cos phi d phi j cap, and solve for its magnitude. Magnitude gives the value r sin theta d phi e phi cap equal to delta r, and its magnitude after division we get the value minus sin phi I cap plus cos phi j cap. Now it's time to calculate velocity. The velocity of this particle is defined as time rate change of position vector. Mathematically we can write v vector is equal to dr vector upon dt. After differentiation it gives two values, that is r dot er cap plus r er cap dot. Here in spherical system the unit vector er cap already calculated. On differentiate we get er cap dot is equal to theta dot e theta cap plus phi dot sin theta e phi cap. On using this equation we get the velocity equal to v vector equal to r dot er cap plus r theta dot e theta cap plus r phi sin theta e phi cap. The value of magnitude is velocity given by the squaring of radial theta and phi vectors. Now it's time to calculate expression for acceleration. Mathematically it can be written as a vector equal to dv vector upon dt d by dt of r dot er cap plus r theta dot e theta cap plus r phi dot sin theta e phi cap. On differentiating and solving we get two terms e theta cap dot and e phi cap dot. Firstly solve e theta cap dot, which gives the value minus theta dot er cap plus phi dot cos theta e phi cap. Similarly e phi cap dot equal to minus phi dot sin theta er cap plus cos theta e theta cap. After substituting the values of er cap and e theta cap and e phi cap in a vector equation, we get acceleration equal to in three components. First one is radial component, second one is theta component, third one is phi component. Magnitude of acceleration can also be calculated by squaring of these three components.